What's up, everyone? Today we're going to be doing geometrical figures equal in area to other figures, and this is the first video that we're going to be doing in the series of study guides coming up, leading up to the CSEC examinations for technical drawing. So in today's tutorial, we'll be looking at how to, I'm going to explain how we go about achieving the goal of finding a rectangle that would be equal in area to other figures. Okay, so if you have another figure such as a triangle, a rhombus, a trapezium, any kind of plane figure, we can find the area of that figure, and we can change it into another figure, okay, with the same area. Okay, so I'm going to be doing that right now. As in the previous video, make sure you have your tools, your geometry set, all that is necessary to start drawing, okay, because we will need them. Okay, so make sure you have them. If you don't have them yet, get to the store, get to town, buy your geometry set, bring it here, look at the video, start drawing, and you'll be fine. Okay, so let's go. Okay, so in this tutorial, we'll start with rectangles. As you can see here, rectangles equal in area to right, acute, and obtuse triangles. If you don't know what a right angle is, an acute angle, and an obtuse triangle, you should Google it. A right triangle is a triangle with 90 degrees. An acute triangle is a triangle that has less than 90 degrees on all corners. An obtuse triangle is a triangle that has one triangle that is greater than 90 degrees, okay? And all the others are less than 90 degrees. So if you look at the first shape, this is called a parallelogram, and a parallelogram is a plane figure that has parallel lines going in two directions. So you have a line that is parallel. A parallel line are lines that go in the same direction but never meet. So if you look at this one and that one, they are going in the same direction but they will never meet. AB, which is this horizontal line, and DC, they are going in the same direction but they never meet. Okay, so this is what you call a parallelogram. Okay, and the area of a space, if you look at the dashed lines or the hidden lines, you will see a rectangle, a basic rectangle. Okay, so AFEB, that is a normal rectangle. Okay, if you read here, I don't know if you can see that, the area of the parallelogram ABCD, so the parallelogram is this irregular shape right here, is equal to the area of the rectangle. Okay, so all that's happening is it's shifting to the left, if you realize that. So it's shifting to the left, and the area of the rectangle is equal to the area of the parallelogram. Okay, here you can see, this can be seen if the triangle AFD, so AFD, and the triangle has three sides, so side AF, side FD, and side AD was accurately removed from the parallelogram, okay, and repositioned as triangle BEC. So this triangle right here, if you remove it and you place it over here, you would get the square. Okay, so this triangle right here, if you remove it, nothing would be here. You would have a straight line coming down, starting the rectangle. If you move it over here, you would finish the rectangle BEC, or yeah, BEC. Okay, and a rectangle of equal area would be produced. Okay, the next one is rectangle and a right triangle. Okay, so the area of a rectangle is length multiplied by height. Okay, so the length is going across horizontally and the height is going up, we usually say. Okay, so length times height is the area of the rectangle. Okay, and we usually put that as L times H. Okay, so length times height. Okay, so always remember, when you're looking at the area of something, you want to look at the length and multiply it by the height. Okay, if it's a rectangle. Okay, so the area of the right triangle, and remember what we said a right triangle is? The right triangle is the 90 degree, and a triangle with 90 degree in it always has to have 90 degrees in it. Okay, all right, so the area of the right triangle is the base. Okay, so the base of a triangle is the bottom of the triangle. It's usually horizontal, but it can be diagonal. Okay, so the bottom of the triangle is BC, and the area of the triangle is the base multiplied by half of the height. Okay, so if you look at it, the area of the triangle is B multiplied, so B would be the length of DC. Okay, multiplied by half of the height. Okay, so the base B multiplied by half of the height is equal to the area of the triangle. So we have the area of the triangle right here. The height of the triangle would, if you look at it, would be AE. This is the total height. So the base times half of the height, which is AD, because this is half of the total thing. This distance is equal to that distance, will be equal to the area of the triangle. Okay, this can be seen in rectangle ABCD. So ABCD rectangle and triangle ECD. Okay, because the height AD is equal to EA, the height AD is equal to EA because it's half of it. The hypotenuse EC, and if you don't know what the hypotenuse is, look it up. The hypotenuse is the longest part of the longest side of the any triangle. Okay, so because height AD, look at the drawing, is equal to EA, and hypotenuse EC intersects AB at midpoint F. That would create that means the area of the triangle is equal to the area of the rectangle. Okay, again it says height AD times length DC is equal to length DC times half the height of ED. So half the height of ED is AD. Okay, so height AD is equal to half the height of ED, which means this side is equal to that side. Okay, so basically they're saying this is the rectangle and this is the triangle. Okay, so they both share the same area. Okay, the reason why we're doing this is because when you're drawing plans or when you're surveying a certain area of land, you need to know how to simplify the area of a plot. Okay, or the area of any land or anything. Okay, so you need to know how to simplify it. And to simplify it, you need to put it in a simpler form, which would be like a rectangle. Okay. All right. And that would make it easier to price your land and, you know, draw your drawings and that kind of stuff, and make estimates for materials and them kind of things. So that's why you need to know how to find areas for different figures. Okay. It can also be seen that if triangle FBC was accurately removed and repositioned as triangle EFA, so if triangle FBC, here is FBC, FBC, this triangle right here, if triangle FBC was accurately removed, so if we took this out and reposition it as EFA, if we took this out, turn it around and put it up here, you would see that it's the same thing. Okay, so the same area, all you're doing is moving around different parts of the rectangle to form a triangle, and vice versa. Okay. All right. Rectangles, let's move on to the next one. Rectangle and acute triangle, all internal angles are less than 90. Okay, so for the acute triangle, we explain it up there, all internal angles less than 90. The area of the rectangle is length is EC, which is the height, times EF, which is across here. And if you're looking at a rectangle and you want to find the area, you can find the area of the top line or the bottom line. It doesn't matter because they are the same length. Okay, so for the area of this one above here, you realize they say DC. You can also say AB because AB is the length of DC. Same length. Okay. All right. So the area of rectangle is EC times EF, and the area of the triangle is CB times half of AD. Okay. So CB is the length right here, half of AB right here. So all you needed to do is find the height right here, the perpendicular height, and then find half of it, and you would get the length of EF, okay, in order to form the triangle. Okay, and again, it can be seen by moving this triangle right here and moving it up here, and also moving this triangle right here and moving it up here. So you're basically cutting out stuff and making the triangle out of it. Okay. You can also do this with paper. So if you have a piece of paper and you want to make a different shape, you can cut it out and move that cutout in a different area. Okay. All right. So let's move on to figure 1.4 right here, and the rectangle and obtuse triangle, one internal angle is greater than 90 degrees. Okay, as we said before, an obtuse triangle, an obtuse angle, not to be confused with an obtuse triangle, is any angle that is greater than 90 degrees. Okay, all right. So in order to create a rectangle from an obtuse angle, this angle above here is greater than 90 degrees, and it's similar to this one. Okay, so all you have to do is find the total height of the triangle, find half of the height, which is AF, half of AF. Once you know half of AF, you can draw your rectangle. Okay, so if you find half of AF, half of AF gonna be DC, so you know one side or one height of the rectangle. You put it on the other side and you draw your rectangle, and you have the same area. Okay, so angle GAI, let's go through it. Angle GAI, and when you say angle GAI, they're talking about the center letter. Okay, so they're talking about the angle of the center letter. Okay, so if it's GAI, they're talking about angle A. So angle A, as we said, was greater than 90 degrees, okay? And it says it here. The area of rectangle CD and DE, the area of the rectangle is CD, which is the height, times DE, which is the length, okay? So length times height. Area is always length times height, okay? Okay, so the area is CB. The area of the triangle now is CB, which is equal to DE times half of the height, okay, the total height. So half of AF, and whatever you get from dividing it by 2, it will become DC and EB, okay? And that's how we get the areas of different shapes into a rectangle. Okay, so what we're gonna do now is construct. If you look at here, you're gonna look at how to construct a square equal to the area of an irregular polygon. Okay, so a polygon is an object or a plane figure with sides that start from a triangle going up to a square, rectangle, hexagon, octagon. Google polygon so you know how many sides each one is called. Okay, so you have heptagon, octagon is 8-sided figure, nonagon is a 9-sided figure. So if you look at the dollar that you have, the EC dollar, you realize it has many sides. So it is a polygon. Okay, so anything with a number of sides is called, any plane figure with a number of sides, it's called a polygon. Okay, so what we're gonna do is change this polygon. This has 1, 2, 3, 4 sides, and we're gonna change this irregular polygon because it doesn't look like a square, so it would be hard to, you know, estimate different things that you need for that space. Okay, so the best thing to do is to change it into a square figure or rectangular figure. Okay, it would make your work a lot more easier. Okay, so this is all you need to do from this figure. Okay, there are 3 stages that you have to go through in order to complete this objective. And stage 1, it says here, the area of polygon ABCD, polygon ABCD, which is highlighted darker, can be expressed as a triangle of the same area. Okay, so let's draw ABCD, and you can draw it at, they didn't specify a specific angle for each one, so let's just draw ABCD roughly in the same figure, and then we'll move from there. So get your geometry sets and start drawing. Okay, so as you can see, we have something similar to what we have on the paper right here, and we're gonna label it the same way. So A, we're gonna label the corners A, B is up here, C is across here, and D would be down here. Okay, alright, so the first thing we're gonna do after you've completed that is join B to D. Okay, so we know where the corner B is, and when we say B, we're talking about where the 2 lines meet. Okay, so B is right here. We're gonna join it to D, and we're gonna join it with a dash line or a hidden line. Okay, a dash line or a hidden line. So we're just gonna draw it right in here. Do that, and you should have that right there. So we're basically just following the instructions. That's all you have to do, and practice it, and you'll perfect it. Okay, second step is to draw a line from C to E parallel to BD. Okay, so C is right here. We're going to draw a line that is parallel. Remember, parallel is lines going in the same direction. So BD is going in that direction. CE will also have to go in that direction. Okay, and there are different ways to do this. The easiest way that you can do it is to take two set squares. So your geometry set has two set squares, the 3060, as I said in the last video, and the 45. All you have to do is take your set square, line it up with BD, because the book says draw a line from CE parallel to BD. So you put your 45 on B to D, make sure it's lined up like that, and then you take your other ruler, or it could be a set square, and you're gonna put this ruler on top of the 45 ruler, and then you're gonna hold down this one, make sure it doesn't move. Whatever you do, make sure it doesn't. If it moves, then you set it at BD, and then you slide it along, if you can see that, until it reaches C. Okay, once it reaches the corner C, you can hold down the 45, and then you can draw your dash lines. Okay, so just draw your dash lines coming down this way. All right, so after you've done that, you're going to extend the line AD across, and this is also going to be a dash line. Extend the line AD until it reaches this line. So make sure you draw this line long enough so that they meet. If they don't meet, then you go back to it and you draw it until they meet. Okay, so you should have this. You can erase now the extra stuff and label it. What is this going to be? According to the book, it's going to be E. Okay, so if you look right there, you see CE. Okay, these lines actually, they don't have them dashed, so you can the book doesn't have them dashed, so you can make them solid and solid. Okay, the only dash line is the one in the center. Okay, okay, so after you've done that, you're gonna label it E. Okay, so we have BD so far, and we have CE also. Okay, so let's go back to the book. You're gonna now, number 4 says join B to E. Okay, join B to E. All right, so let's do that, and it's gonna be a dash line. So corner B is gonna go to corner E with a dash line. And when you're drawing dash lines, try and make the dashes equal in length, so it looks much more neater. Okay, all right, always want to make your work look neat. All right, so we have created 2 triangles. If you can see, one is right here and the other one is up here. So 1, 2, 3, this is the triangle right here, and 1, 2, 3. So we created 2 triangles from the previous irregular polygon. Okay, all right, so we look down here, the area of the triangle BDC, and we can use this one, the area of the triangle BDC. So this triangle right here, BDC, I know it's confusing, but just try and follow. BDC is equal to the area of the triangle BDE. Okay, triangle BDE. So BDC is equal to the triangle BDE. Okay, This is because both triangles have the same base BD. Okay, so this triangle with the dashed lines, it has the same base, which is BD, the first dashed line that we drew, and this triangle has the same base BD also. Okay, so this is because both triangles have the same base BD and the same height. Okay, as they are between two parallel lines BD and CE. Okay, so the two parallel lines are BD, and remember we drew CE over there, so these two are running in the same direction according to the set square method that we did. Okay, so once you have two triangles in between, which is this one, and this one, BDE and BDC, once they are in between the two parallel lines, they will have the same height, and as they are between two parallel lines, they will have the same area also. Okay, so down here it explains which triangles are equal to each other. Okay, so look at them and you can see what we need for the next step. Okay, so for the next step we're gonna take you can see that ABE, triangle ABE, and we're gonna move it over into a next drawing. Okay, so let's do that. Okay, so the drawing that we have currently, we only need ABE, as we said, and we're gonna move over to create this triangle. Okay, what I'm gonna do is erase those areas that we don't need, and this is